So in this question we are expected to find the current through the 5 ohm resistor. So in order to do that, applying Norton's principle, we just have to short circuit it. And when we short circuit, let's redraw. So when you short circuit it, you see that current on the 5 ohm resistor becomes IN. So now to know the direction that it is moving will simply be determined by the signs on this. Notice that this is the bigger side of the voltage of the battery. This is the smaller side, so this is negative, and current enters through positive. So current is entering here. That means that this particular one is going this way. That is, it's moving this way. Why this one now? This current that is here is entering here and leaving, so it's going this way. This current is this way. So you need to note that. Now that you've noted that, you need to also see that since it's going this way, that means IN is going this way. That means whatever it is on the ground, my reference should have been here, but I can't use it as reference. My reference has to be this way, because it's almost as though everything here is trying to move to this axis. So if that be the case, that means the current down here, it has the option of going this way and going this way. That means this current has to move this way. So the next thing is to draft out your load. So whenever what we are doing is nodal analysis, anything Newton's theorem is more of nodal analysis. So let's get all the nodes. So I start with a voltage and I stop with a resistor, that is with a source. So this is the first node. Let's say I call it V1. This is 2 ohms. There's a current moving here. Now the minute I get here, we'll do another one, another node for node 2. This will move like this. Move like this. Once it meets this resistor, it stops. But in between, there are resistors. In between. So this is 3 ohm, 2 ohm, 2 ohm, 2 ohm. So this is V2 because this is node 2. This is how to find node. This is node 1. This first one is node 1. Node 2. If you like, go and be putting that in your diagram. Then the third node is starting from here to this voltage. So I do this is 10 volts. This is the 2 ohm and it's moving in this direction. So now notice something. This 2 ohm that is here is the same ohm that is here. This is node 3. So why this is node 2? Inside, on the inside of the nodes, their current move from higher potential to lower potential. So it's moving from node 2 to node 3. So this one is going down. But node 3 does not include anything like that. So that means it's moving from here to the ground. So let's do for node 4. You start from up, then do ground. So let's do for node 4. Node 4 should be from this voltage down to this place. So I have then in between it you have what am I doing? There's only one that entered it. Let me redraw node 4. Node 4 is actually starting here from the voltage to this resistor. Then in between you have the 3 ohms resistor which is moving down, and call this V4. And notice that it's on the ground, it's the ground. So V4 here is equals to 0. Remember that this one is 2 ohms. So it's 2 ohms. Okay. And this is 7 volts. So then for node 5, the last node this side. So I now have starting from it is the resistor 2 ohms is going this way. Then notice that as it's moving, there is also a branch on this 2 ohms. So that is for V5. This is V5. So that is how to find node. There you have how to find node. So let's progress to now solving. So now let's try to label the currents. We've been able to label the voltages. Let's try to label the currents. So notice that this is the first current. This is the first current. So call it I1. This is that first current I1. This is the second current I2. Call this one I3. Then call this one I4. So this I2 is what is here. It's going down I2. So it's moving from a node to another node on the inside, and on the outside battery is determining the direction. You enter through the positive, then leave through the negative. So and this point is always going to the ground, so the one that is closest to the ground. So even on the inside, when it's supposed to go towards the battery side, if you notice the ground is there that way, you point it to the ground like we did here in I5. This is, so if this is first of all on node 3, we've made this inside node 3 is the I4. Yes, is the I4. This now. So I think it's best, let's do it this way. This is I1. This is I2. This is I3. And this one is I4. That means that leaves us with this being I5. So I'm trying to do it by nodes. So the first node, I check the currents there for the second one. So this is our I5. You might want to say currents should be flowing on different directions. You are not wrong, but at the end of the day, the final push will be determined by the higher potential, because current flows from higher potential to lower potential. So now that I've gotten it, let's now do the equation. So for node 1, so equations. So if in node 1, the equation for node 1 is going to be, let's do this one. I want to come here. Let me keep this. I've seen this, we know what this is. This is the question. So from node 1, I'm going to be having, from node 1, I'm going to be having, notice that if this is what we did here, this is V1, and that means this is V2, and this is V3. Yes, here now node 3, V3. So node 3 has voltage 3, node 2 has voltage 2, node 1 has voltage 1. This is V4 also. That is what did we have, V4 6 now. Everything here is V4, and it's on the ground. While this side is V5. This side is V5. So for node 1, notice that node 1 is having voltage moving and then coming here. So it's between V1 and V4. Remember, everything is V4. So we have current moving from V1 and going to the ground, V4, is equals to 7V. So there is a voltage in between it, which is 7 voltage. So whenever you have a voltage and another voltage and there's a voltage in between, just do the higher potential, that is where the current is entering from and going to, that is minus where it's going to, equals to that middle one. So that since V, we agreed is the ground, V1 minus 0 is equals to 7V. So V1 is equals to 7V. So note, since V4 is the ground or your reference, V4 is equals to 0. So we've gotten these two. Let's go back now. Anytime you do this, immediately you do something like this that has voltage, just the way we've done it, get the super node. How do you get super node? Just mark out all the voltages, that is V4, the 7V and the V1. Take it out, then ask yourself, what currents are entering this V1 and V4, and what currents are leaving V4 and V1. So notice, for V1, I1 is entering it. So anything that is entering, call it positive. I1 positive. That is all entering V1. Now for V4, this current here is I2. Then this current here is I5. That is this current, I5. So I2 is entering it. I2 is entering it. I5 is also entering it. So I2 plus I5. So any other one goes to 0. So I5 entering, I2 entering, I1 entering. So that's the super node. So super node 1 equation. So let's check for the voltages there. Let's check for the voltages there. You can see very well that on this now, in between, I1 is in between, this I1 current is in between I2 and V2 and V1. Now ask yourself, what is the direction of this current? Is this way, is this way. So V2 minus V1, it moves from higher potential to lower potential. So this is actually V2 minus V1. What is the resistor there? It's resistance of 2, so over 2 plus I2. I2 is in between V2 and V4, and V4 is 0. So it's just V2. What is the resistor in between? 3, all over 3, plus I5. I5 is in between V5 and V4, and V4 is 0. So it's just V5 over 2. So equals to 0. Now what is the LCM here? Is 6. So 6 into 2, this will be 3V2 minus 3V1 plus 2V2 plus 3V5 equals to 0. This will come and times this, so that this will become 5V2 minus 3V1 plus 3V5 equals to 0. So I've gotten that. That is super node SN1, super node 1, super node 1 equation. Now let's move to node 2. Check what we have for node 2. Now in node 2, what currents do we have entering node 2? For node 2, I can see that this current is leaving this node to go to node 1. So I have minus I1. So let me write it here. I have minus I1. This one is leaving node 2 too. So minus I2. This is the node. So if it's going this way, it's going to another node. If it's coming here, so minus is now entering. So it's leaving. I2 is leaving. Then let's check. This is I3 is leaving, minus I3. Then this one, I4, it will come here before. So I4 is entering plus I4. Any other current? Let's go to the measure the circuit itself and check. So for node 2, we have I4 entering, I1 leaving, I2 leaving, I3 leaving. So equals to 0. So I1 from here, we've gotten I1 from here to be V2 minus V1 over 2. We've gotten, but it's carrying minus, so let's put the minus in. Then I2, we've gotten it to be minus, I2 is this one, minus v2 over 3. So I don't want to do it twice. So minus, once you introduce minus, you close bracket because it always changes something in the middle. So then I3 is where? I3 is this one. It's in between V2 and V5. So V2 minus V5 because it's coming down all over the resistor in between 2. Close it. Then plus I4 is moving this way. V3 minus V2. V3 minus V2. Then all over the resistor in between. Resistance in between 2. Okay, I don't even need to close this one. So the LCM is 6. So minus 3 V2 plus minus times minus plus 3 V1 then minus 6 into 3 2 V2 3 minus 3 V2 plus minus times minus plus 3 V5 plus this is equals to 0. So plus 3 V3 minus 3 V2. This will come and times 0 equals to 0. So let's not make any mistake. Let me check this before we continue. Okay, so this is going to be, because this will come and times this equals to 0. So let's just solve. This is minus 3 V2 minus 2 minus 3 minus 2 minus 5 minus 8 minus 8 minus 11 V2 then plus V1 is just 1, 3 V1 then what else plus 3 V3 plus 3 V5 equals to 0. This is times 0 is going out. So now notice something. This 3 V1 is 21. V1 is 21. Wait. Yes, I'm coming. Okay, yes. So when you cross over, this is going to be minus 11 V2 plus 3 V3 plus 3 V5. V1 is 7. If you remember when we started, we said V1 is equals to 7 here. So just do 3 times 7 is 21. So it will be plus 21. Crossing over becomes minus 21. So call this our equation 2. That is our equation 2. So now that we have this as our equation 2, let's continue this sign. So let's go back. Let's bring our node. So you've seen everything now. Let's bring our node. That is our circuit. We are carrying it so that it helps us. So see that V3 is having the same situation, is having a voltage in between. So once you have voltage in between, don't just go and be looking at the current. Know that you just need to do super node and that principle of voltage that is higher minus the one lower equals to the middle voltage. So this is going to be, notice that this is moving, current here is moving, entering from the positive, so it's moving from V5. So it's going to be V5 minus V3 equals to what is in between, which is 10 V. So that means that V5 is equals to 10 plus V3, and V3 is also equals to V5 minus 10. So note that, and I've told you, once you do anything that has to do with this kind of thing, find the supernode immediately. How do you find the supernode? Come and remove all the voltages in this place. Just more like say you open circuit this, you open circuit it, and when you do the open circuit, like, or maybe, or just say you cover it, not seeing the voltages. So not open circuit, you short circuit it. If you short circuit everything here, remove this voltage, remove this, it becomes a wire. What currents do you have leaving this area, and what currents do you have entering it? So you can see very well that for the supernode, so SN2, the second supernode, So for the second supernode, the currents you have entering. So it's the same thing as saying go to node 3 and node 5. That's where it's happening. So on node 3, this is I4 leaving. I4 is leaving. Now on node 5, I2 is entering. So plus I2. Then this is I5. I5, okay, I've already read it here. I5 is leaving. Minus I5. What else? So once you are done with doing it 1-1, you can go here and check if you are correct on the main circuit. So you can see I4 leaving this place, leaving node 3 to node 2. I3, yes, I3, yes, I3. Sorry, wait, what did I do? This thing I called I2 is actually I3. So why did I call it I2 here? I hope I've not used this before. So it's supposed to be I3 that is here. This is I3 now, because I5, that is node 5, can't connect with I2. So this is I3. I3 is entering. Then on this, I5 is leaving. So it's important that we don't make mistake, because small thing you might just mistake small thing and you get everything wrong. So everything is equals to 0. So I4, let's check, have we done anything for I4 before? Okay, so let's do it again. So to get I4 now, it will be minus, I4 is in between V3 and V2. V3 minus V2, because the current is moving in this direction. V3 is higher, all over the resistor in between, which is 2, plus, now I3 is in between V3 and V5, and notice, sorry, it's in between V2 and V5. What are you doing? Because this is the resistor that current is flowing through. So it's in between, this is the resistor, this is the I3. So it's in between V2 and V5, and it's moving from V2 to V5 all over the 2. Then minus I5 is in between V5 and V4, and V4 is 0, so it's just V5 all over 2, the resistor in between. So once you've gotten this, everything should be equals to 0. And notice it's just 2, 2, 2, 2 that is there. So it's the same LCM. So LCM is 2. This 2 times 0, it will be 2. So it's just going to be bringing everything down. So it's just minus V3 minus times plus V2. See what I mean? This is 2. 2 here, 1 times everything here is the same thing as saying minus V3, opening this bracket, plus then V2, the same thing here, minus V5. So the same divided 1 times minus V5 equals to 0. This 2 times 0 is 0. So by the time you do it, you now have V3 minus V3 plus 2V2 minus 2V5 minus equals to 0. So this is the supernode, the second supernode. So supernode 2, SN2. So now that you've gotten this, it's now time to start solving out. So let's go back to our first equation. So we have our first equation. I just hope we did not make any mistake, because any small mistake always affect the whole answer. So I'm coming. Okay, so now let's put the first supernode. This is the first supernode, this is the second supernode. Let's put it side to side. So let's put the supernode side to side. So I want to do first one. The first supernode is 5V2 minus 3V1 plus 3. I'm writing it out. God. 3V5 equals to 0. That's the first one. Then the second one is v2 minus 2v2 minus 2v5 equals to 0, 2. Now check out something. And now see that we already know what v1 is. This is v3 now, minus v3. Don't even start, don't start. So this is supposed to be, if this is, let's now substitute here. So this is supposed to be, the first equation is supposed to be 5v2 plus 3v5 equals to 7 here times this is 21, minus 21 crossing over plus 21, equation 1. This one is, so right here you have your supernode equations, your two supernode equations. So I have v3, I have v2, I have v5, I have v2, I have v5. So because the first equation is something like saying 5v2 plus 3v5 equals to v1 is 7 times 3. This should be minus 21. So crossing over is 21 for equation 1. So make v2 such a formula here. This will be v2, okay, 5v2 equals to 21 minus 3v5. Divide both sides by 5. So v2 is equals to 21 minus 3v5 all over 5. So one of the issues students do have is, always remember, supernode to supernode, node to node. That's how I do it. So carry this equation 1, carry this value of v2 in equation 1 for your supernode and substitute here, so that I now have minus inside equation 2. So this will now be, for equation 2 will now be minus v3 minus 2. v2 will now be 21 minus 3v5 all over 5, then minus 2v5 equals to 0. So then remember, if you check it, you now remember that v3 somewhere, we did that v3 somewhere is v5 minus 10. So this is going to be the sentence as saying, let me write everything here. With this v2, how come I'm putting v2? This is v2 now in the first one. The first equation, v2. Okay, yes. So in the second, so since I can say that in this second equation, since everything here is minus, can change everything here to plus. Oh wait, let's check something. So we made mistake with our sign. Notice that when we solved for node 2 equation, it was minus v3 plus 2v2 minus 2v5. So it's supposed to be minus v3. That is, this is where we got it wrong. Minus v3 plus 2v2, yes, plus 2v2 minus 2v5. So now we can solve. Now we can solve. So that this now becomes v3, replace v3 with this value, which is v. So this is going to be, let's carry this, is going to be 2 into 21 minus, okay, 2 into 21, let's do it this way, 2 into 21, 42, 2 into 3 minus 6v5 all over 5. Then v3 is v5 minus 10, so plus 10 minus 2v5 equals to 0. So you can very well see that when you solve the LCM is 5. So let's put this is going to be presenting as saying, pulling everything together, this is going to be 42 minus 6v5, this will go, then plus, sorry, this is minus here, this minus will make this to change to plus, Yes. So this is going to be minus 5v5 plus 50 minus 10v5 equals to 0. And when you solve this, this is going to be 92 minus 21v5 equals to 0. So this is going to be v5 equals to minus 92 over minus 21, which is equals to 4.38 volts. This is the correct answer for v5. So you now need to go back and remember that v3, remember that v3 is equals to v5 minus 10, which is 4.38 minus 10, which is equals to if you do it, it's going to be minus 5.62 volts for v3. So for v3, so that means if you now, you need to also remember that v2 is equals to 21 from that equation minus 3v5 all over 5. So that means it's going to be 21 minus 3 into 4.38 over 5, which is equals to 21 minus 13.14 over 5. So v2 is equals to 7.86 equals to 7.86 over 5, which is equals to 1.57. So that means we've gotten v1 to be 7, v2 to be 1.57, v3 to be minus 5.62, v4 is the ground, which is 0, and v5 we have it to be 4.38 volts. So we've gotten all the voltages. Now to get the current, you need to remember that let me pull out the v. Okay, yes, we now know that v1 is 7, v2 is 1.57, v3 is minus 5.62, v4 is 0, and v5 is 4.38. v5 is equals to 4.38. So now that we've gotten that, we need to remember that our I1 is in between, see our I1 in between v2 and v1, v2 minus v1 all over 2, v2 minus v1 all over 2, and that is the same thing as saying 1.57 minus 7 all over 2, which is going to be equals to minus 5.43 all over 2, so equals to minus 2.72 amperes I1. But you need to know that this thing, negative sign, just means that it is going, should I say, if you notice, this current is moving from this way. I1 is going from higher potential to lower potential, is decreasing. So it's more like saying decrease. This sign means decrease. The actual value is 2.72, so if the negative shows decrease. So for I2 is equals to, that is our I2, is in between V2 and V4. So V2 minus 0 is V2 all over 3. This is the resistance in between. So V2 over 3, which is equals to V2 is 1.57 divided by 3 is equals to 0.52 ampere. So the mistake you might make is always remember, do node when you want to make any equation. If it's node you are solving, use node and node. If it's supernode and supernode, if you make V2 maybe subject of a formula using supernode, you substitute into another supernode. Don't go and carry a node equation from somewhere, make V2, then come and substitute inside supernode. It might make your answer to be wrong. It will make your answer to be wrong, not mine. So for I3 is in between, check it out, V2 and V5 is coming down, higher potential V2, lower potential V5. So V2 minus V5 all over the resistance in between, which is 2. So V2 minus V5 all over 2, which is equals to 1.57 minus 4.38 all over 2, which is equals to minus 2.81 over 2, which is equals to minus 1.41 ampere. Now for I4 is in between V3 and V2 over 2. So V3 minus V2 over 2, which is equals to minus 5.62 minus 1.57 all over 2, which is equals to minus 7.19 over 2, which is equals to minus 3.6 ampere. Now I5 is equals to, I5 is in between V5 and V4, and V4 is 0, so V5 over 2, so V5 over 2, which is equals to 4.38 over 2, so which is equals to 2.19 ampere. So you now need to notice that for IN, for you to get IN, this current here, this I4 will flow and enter here, and if you enter here, the current that enters here is I3, this particular current here, so I3, then it will continue. So it's going to be that IN is simply I4 minus the IN, that is, it's supposed to be I4 going, but I4 will come and lose a current here. The current that will leave here is the I3, so what is remaining is IN. So I4 minus I3 is IN. So I4 minus I3 is equals to IN. And also notice, as this current is moving, IN now is the same thing as saying if it come, it will enter here, lose, something will leave, and then this one will continue here. So IN is simply also can be gotten by saying the current leaving, which is I2 is leaving here, I2 is leaving here, while IN is entering. So I2 plus IN should give you I2 plus I1, because they are both leaving and this one is entering this node. Remember Kirchhoff's law, the current entering is equals to the current leaving. So IN should be equals to this current leaving, the two currents leaving, while it is entering. So it's going to be the same thing as saying I1 plus I2 is equals to IN. So if you use the same Kirchhoff's principle, you can also say that coming here, this is IN leaving, I3 leaving, I4 is the only one entering. So I4 is equals to IN and I3. Yes, so I4, naturally I4 is equals to I3 plus IN, but if we don't know IN, it simply means IN will now be equals to I4 minus I3. So let's check if it's true. So that means that I'm going to be having I4 is minus 3.6. Now minus I3 is so minus I3 is minus 1.41, so minus 1.41 equals to IN. So by the time you do it, this changes to plus, so IN will be equals to minus 2.19, which is approximately minus 2.2, so IN, so ampere. And you need to note that this minus just shows that it is decreasing, and it's true because it's going towards this axis to the ground, so it's decreasing. So, or you say it's, yes, so it's in that direction. That's what it shows. I hear some people say it shows you chose the wrong side. No, we did not choose the wrong side. It's just to show you that it is reducing, the current is decreasing. So if that be the case, I move to prove it. So I1 plus I2, so I1 is minus 2.72 plus I2 is 0.52 equals to IN. If you punch this, you're getting, for I2 you are getting minus 2.2, so ampere. So you are correct. This is the final answer. So don't go and be doing chat GBT for this one. To carry you around, carry you around, carry you around till if you keep questioning it well before you get the correct answer. What we've given you now is how it should be done. Subscribe to the channel. Alright, welcome to Academic Daddy's class. So in today's video, we are asked to find the current in the 5 ohm resistor using Norton's theorem. So all I need to do in order to do this is to get out the notes. So I'll have this. This is my first node. So let's call it V1. The first node. This is the 2 ohm resistor. Now notice that this is positive, the positive terminal. So the current that is flowing here, we have to move from this point and enter here. Then let's get that node 2. Node 2 is going to be everything here. And everything from here. But notice they say we should find the current in the 5 ohm resistor. So we have to short circuit this. So this was short circuited. So if I short circuit that 5 ohms now, it becomes my IN. And since this one is already going this way, that means that IN is going in this direction. That is the Norton current I'm to find. So on the outside, current flows in the direction of the battery, how it's entering the battery. It enters from the positive and leaves on the negative. While on the inside, current flows from a particular node to another node. That is from the first node to the second node. So this is node 2. So node 2 current will move downwards. That is going to the third node, even though we don't know it yet. And notice that all the nodes are being stopped by a source. This resistor is a source, a source, a source, a source. This is voltage here. It started with this and then stopped at this. So let's move to node 3. So when you start from the top part, node 3 will now be everything here and this one. So that's for node 3. So node 3, and that means that this current now, if this is negative, this is positive, current will be entering from this part and leaving here. So that means that the current here is moving in this direction, so like this for node 3. Now for node 4, that is, so we've done the ground, the up, then you come back and do the ground. So this is positive, this is negative, you have this, you have this, then come and make this, then along the line as it was going, this is 3 ohms, this is 7 volts. So if that be the case, you can now see very well that this 3 ohms is moving down here, this one is moving down. So this is V4. So let's call this one V3. Everything here is V2 because it's node 2. So V3, this is V4, this is also V4 because this is node 4. The voltage in node 4 is called voltage in node 4 is called V4. That's voltage 4. And I've noted this for the node 5, the 5th node. And notice that there is 2 ohms here. These 2 ohms, how will it move? These 2 ohms, how will it move? Since we said that on the ground, what determines what is happening on the outside? on the outside. What determines what is happening is how current is entering. Remember that current is entering this way for this one, because this is positive, it's entering here. And if current is entering here, then notice that this one, current is entering here, this is positive. This is positive, current is going this way. If current is going this way, it simply means that on this outside, this current that is here, normally it's supposed to try to move to the ground, but because of the fact that I see that this is positive, it means that the current here is going in this direction. So that means that this current here is actually moving in this direction. Yes, since on the outside path voltage determines, I could have pointed it to the ground. I could have said everything is trying to move to the ground, because this is going to the ground, this is also going to the ground. But okay, let's move to note 5, then come back to that. Note 5 is going to be so remember that these 2 ohms here is coming down, and these 2 ohms here is the 2 ohms in this one. So this is V5. So they leave it. We could have said let it go to the